Hey, hi, good evening, everyone. Good evening, friends. Right. So, welcome to our 30 days free short term training from Python to AI. In the past couple of days, it's been a while that we have started these sessions and we're getting good feedback with respect to all the sessions that we have covered so far. Right. So, yesterday in the previous class, we started with data visualization. Under data preparation, the second phase of CRISP MLQ, another second phase of CRISP MLQ, that is data preparation. We have in total three phases, three sub phases. One is EDA, the next one is data pre-processing, and the final one is feature engineering. Right. So data preparation again under EDA, we started discussing EDA. Under EDA, we understood all the four moments: first moment, second moment, third moment, and fourth moment. And now we are going to discuss data visualization. We are in data visualization phase. So we'll quickly understand what exactly these four moments help us to understand with respect to any data, okay, any structured data. Then we'll discuss about data visualization subphase. So as part of EDA, we have business moments. EDA stands for Exploratory Data Analysis. Okay, so it consumes majority of the time because it is generally performed on one column at a time. Okay, it's a univariate process, taking one column at a time and performing first moment, second moment, third moment, and graphical representation. Nothing but data visualization. So first moment, what does first moment talk about, friends? What does first moment capture? What does first moment capture? First moment captures the center value, the representative value. Okay, so this captures the center value or the representative value. What about second moment? Second moment captures the spread from the center. Okay, what about third moment? Third moment talks about the direction of spread from the center. Is it towards right or left? Okay, so in that way, it talks about all these the direction of spread from the center. And finally, fourth moment, which talks about peakedness. Either we have a sharp peak or tall peak in our data. No, our data when we try to visualize the data, is it giving a sharp peak or tail peak with long tails or a wide peak with no tails? You'll understand with respect to fourth moment. Right. So first moment, under first moment we have mean, median, mode as the measures. Mean is represented with the mu, and the formula for mean is sigma of x by n. Right. So mean has a disadvantage. It's not a disadvantage. It's a challenge with mean. It gets influenced by outliers. Okay. So mean is not generally considered if the data has outliers. Then we have median coming into the picture. Median is nothing but middlemost value of an ordered data set. So median is not influenced by outliers, so we can consider median. We also have mode as a measure under first moment, which is used to calculate for non-numeric data as well, categorical data as well, whereas mode represents the most repeated value. Right? Yes. Under second moment, we have variance, standard deviation, and range. What about variance? What is the formula for variance? Variance is represented with sigma square, and the formula is summation of x minus mu whole square by n. Okay, so what exactly it talks about? It is talking about the spread from the center. From the center, what is the spread for each and every value? But the disadvantage of considering variance is it gives us the squared spread. Since I want the original spread, you have to go and take standard deviation, which is nothing but square root of variance. Right? Yes. Then we also have range. Range is nothing but max minus min. Maximum value minus minimum value in the data. Right? So all of these are part of second moment business decision. Okay, right. Then comes the third moment. So what is the measure that we are using as part of third moment? Skewness. What is the formula for skewness? Skewness is given with expected value of x minus mu by sigma raised to the power 3. Good. Okay. And this skewness is of three types: positive, negative, no skew. What is the other name for positive skewed data? It's nothing but right skewed data. What is the other name for negative skewed data? Is also called as left skewed data. So no skewed data is nothing but normally distributed data. Z curve. Okay, let us not go into this Z curve, statistics and all. But positive skewed data is also called as right skewed data. Negative skewness is also called as left skewed data. We have understood all these topics in the previous session. For positive skewed data, tell me the relation between mean, median, and mode. For positive skewed data, tell me the relation between mean, median, and mode. Mean, median, mode. Okay, it is nothing but mean greater than, median greater than, mode. Okay, mean is greater than, median is greater than, mode. For a positive skewed data, you will find a long or tall curve, towards your right side. Why? Because of outliers towards the right side. Okay, so since you find outliers towards right side, obviously mean value gets pulled. So mean from the center comes near to the outliers, the extreme values. So mean greater than, median greater than, mode will be the relation. What about negative skewed data? What is the relation between negative skewed data for the three measures? It is nothing but the opposite of this relation. Mean less than, median less than, mode. Right? So this will represent for negative skewed data or left skewed data. What will be the relation for no skewed data or normally distributed data? For no skewed data, it will be like mean is equals to median is equals to mode. That's it. Good. Right? So we have understood, all the skewness types and the formula. It was practically done on iris data set, and I have requested you guys to do it on multiple data sets. Right. So this is the actual this is the part of third moment. Now fourth moment, the measure that we actually do it as part of fourth moment is kurtosis. What is the formula for kurtosis? expected value of x minus mu by sigma raised to the power 4 minus 3. Okay, since it is fourth moment, it's better you remember it as like that. Fourth moment power 4. Okay, so what is this 3 indicating, friends? In the formula, what does this 3 indicate? Can someone tell me what is this 3 indicating in the formula? Use chart and tell me what is this 3 indicating. 3 is actually indicating kurtosis of, it is nothing but it is the kurtosis value of z. What is z? Z is nothing but normally distributed data. Okay, if you take normally distributed data, if you cut exactly at the center, you'll get two identical parts, right? So that such kind of data is nothing but z data, normally distributed data. Okay, and kurtosis value of z is 3. Since you are comparing with z, you are removing the value that you get from 3 and you are checking whether this value is positive or negative. Okay, so positive or negative, based on that you can tell positive kurtosis or negative kurtosis. If you get 0, it is obviously representing a normally distributed data, right? So for a positive kurtosis, what is the name of a positive kurtosis curve called? Leptokurtic. What is the name for negative kurtosis called? Platykurtic. What is the name given for the curve which has kurtosis as 0? Mesokurtic. Okay, remember those names as well, because in general they will not be asked, but if it was asked, you should be in a position to answer these questions, right? So this is actually what we have discussed with respect to all the four moments, right? First moment, second moment, third moment, and fourth moment. For a positive kurtosis data, you will find a sharp peak or a tall peak with long tails, whereas for negative kurtosis data, you will find wide peak with no tails. Right? All these were being discussed. Now, no, yesterday we started with data visualization. Visualization is nothing but pictorially representing the data. Okay, so there is a famous proverb, friends. Can someone tell me what is the famous proverb that we have on visualization? Are you guys aware of that proverb? A picture speaks 1,000 words. Might be, just try to recollect. A picture speaks 1,000 words. That means if you just visualize any picture, an image, it will give you 1,000 kinds of insights. So we always try to visualize the data. When you try to visualize the data, you get more insights instead of getting the values. Yes, you get more words. So under data visualization, we have two types: univariate, and the next one is bivariate. What is the meaning of univariate and bivariate, friends? What is the meaning for univariate plots and bivariate plots? Univariate means, trying to visualize one column at a time, single column. Whereas bivariate means working on or trying to visualize two column data at a time. Okay, so under univariate, we understood bar plot, histogram, and box plot. Am I right? What is the purpose of bar plot? The purpose of bar plot is to understand the data distribution. Data distribution. But there is a challenge with bar plot. Even though still it is helping us to understand the data distribution, there is a challenge with the bar plot. What is a challenge? When you try to visualize a bar plot on large data, yes. So when you try to visualize bar plot on large data, these bars that you see in this image, in this visualization, they get squeezed and bars get converted to lines. Okay, so bar plot is not a good visualization for understanding the data distribution traditionally. So in that cases, we'll go for histogram, because histogram is also used to understand data distribution only. Okay, it is also used to understand data distribution. But what makes the difference? In histogram, the data, you see, you observe, I'm taking age column, but am I taking each and every column of age? Each and every value of age? No. In histogram, we make data into bins. See, 50 to 60, 60 to 70, 70 to 80. Okay, depending on the value of a person, depending on the value of age of a person, they fall into that respective bin. Right? So this grouping happens. This is nothing but discretization. We'll discuss this in the next topic. Okay, so histogram by default does binning. Okay, it creates bins. Okay, then we can understand the data distribution. Now it's clear. Okay, so histogram, the main purpose of visualizing histogram is to understand data distribution, and the secondary purpose of visualizing histogram is we can comment on outliers. See, whatever I am just talking, observe properly. We can comment on outliers. That means we can tell whether there are outliers, the presence of outliers or not. But are we sure? No. 100% we are not sure, but we can comment it as there might be. See, if a person who has age, say 95, he'll fall into this bin, he or she will fall into this bin, yes. So 95 might or may or may not be an outlier, but we can tell there is a chance of being an outlier. Are we sure? No. Okay, so we can just comment, like giving like a probability statement. Okay, but how do you confirm it? I confirm it using Boxplot. Why? Because Boxplot is the only visualization which talks about outliers. You can see the outliers in the visualization, okay, of Boxplot. The primary purpose of Boxplot is to comment on outliers with confidence. Yes, there are outliers in the data. No, there are no outliers in the data. In that way, you can comment. You are 100% sure. Okay, what is the secondary purpose of Boxplot? It talks about data distribution. So if you observe histogram and Boxplot, the primary purpose of histogram became secondary purpose of Boxplot, and the primary purpose of Boxplot became secondary purpose of histogram. Okay, so that makes the difference, friends. Right? So I'll just histogram is very easy to understand, but when it comes to Boxplot being a new feature, it's a new visualization for us, right? So let us understand Boxplot well. Under Boxplot there are different parts. The first one is lower limit. Lower limit. Then the second one is Q1. Third one is Q2. This is also called as median. Okay. Fourth one is Q3. And fifth one is upper limit. Okay. So let us understand what are these parts. If you take a box plot, this box plot is also called as whisker plot. It is also called as box and whisker. What is this box plot? What is this whisker plot? Why it is named as box and whisker? If that is the question, if you have in your mind, you see a box in the plot. So because of this box, it is named as box plot. And these two tails that you are seeing are called as whiskers. Okay, because of these two whiskers, it is named as whisker plot. Since it has both box and whisker, it is named as box and whisker plot. Right? So let us understand what is these whiskers, what are these upper limit, lower limit, what is Q1, Q2, Q3, we'll understand. The extreme left portion is called as lower limit. This lower limit is calculated using Q1 minus 1.5 times of IQR. Okay, so what is this? So in order to understand lower limit, you have to understand Q1 and IQR. Am I right? Yes. So what is Q1? Q1 is called as 25th percentile. Okay, so assuming data is 100%, I'm making data into four parts. 100% by 4. It's nothing but 25%. So make this box plot also into four parts. Part 1, 2, 3, and this is 4. So each part contains 25% of the data. That is the assumption that we have. 25, 25, 25, and 25. Okay, since I'm starting from the left, okay, from 0 until after you complete one part, you have 25% of the information, right? So this part is nothing but 25th percentile, also called as Q1, because it holds 25% of the data. Then when you come to the next part, 25 plus 25. So 25 plus 25 is 50. So you will have, it is named as 25th percentile, which is Q2. This is nothing but Q2, also called as median. Then Q3 is nothing but 75th percentile, 25 plus 25 plus 25. 75th percentile. And finally, the upper limit. In order to calculate upper limit, you are supposed to use Q3 plus 1.5 times of IQR. Now let us talk about IQR. What is this IQR? IQR is nothing but interquartile range. I repeat, interquartile range. The middle box that you observe is called as IQR. Okay, how can we get this range? I'll get the difference of Q3 and Q1, and that gives me the range. I hope it's clear. So this will give me IQR, and when I substitute IQR in the formula, I get lower limit, and I'll do the same For upper limit also, I'll substitute Q3 and IQR. I'll get upper limit. Once after getting lower limit, upper limit, I have to check whether we have any values which lie beyond these limits. Those values are called as outliers. Okay, for example, I take salaries of an organization. There is a column called salaries, and these salaries I'm taking into consideration, and I'm calculating the limits. The lower limit that I got is 100. Upper limit that I got is 1000. Okay, I being an employee of this company, my salary, if my salary is just 80 rupees, okay, will I lie beyond this range? Will I lie between upper limit and lower limit, or beyond lower limit? I will lie beyond lower limit, behind. Okay, so I'll be somewhere here. This is 100, right? So I'm not inside of 100 and 1000. I'm not between 100 and 1000. Okay, I'm behind 100. So I'll be an outlier in this case. Right? I'm less than the lower limit. So that is the reason I'll be an outlier in the organization. For example, let me take my CEO who is getting paid 2000 rupees. Might be somewhere he'll lie here. So this is my CEO. Is he an outlier in this case? Yes. He is also an outlier. But are we both lying in the same direction? No. I am towards the lower limit side and CEO is towards the upper limit side. Okay. So that makes the difference, friends. Right. So I hope now the box plot is clear. Still, if you have any kind of questions, please let me know immediately so that I'll try to clear all your doubts. If not, we'll go to the hands-on part. Any questions with respect to box plot? Is it clear? Shall we proceed? Right. Now, let us jump into the hands-on. For that, I'm taking the same iris data only, friends. I'm not trying on any other data sets, but I want you guys to try it on other data sets. Okay, so please work on other data sets. Implement the same. You need not do anything new. Okay, just implement as is. Right. So first step is importing the required packages. Okay. For that, I'm importing pandas as PD. Pandas is a module, okay, which is used to, what is the use of pandas? Pandas is used for data manipulation. Okay, then I'm importing NumPy as NP, and NumPy is used for numerical calculations. Okay, then I'm importing matplotlib. Okay, from matplotlib, am I importing the complete? Okay, this is the first time we are getting a new, package, right? So let me do one thing. See, I'm importing the complete pandas and I'm importing the complete NumPy. Okay, importing as is, but giving an alias name, a shortcut name. That's fine. But what's happening with respect to the third package, matplotlib? Am I importing the complete matplotlib? No. Assume matplotlib is a folder in your system. Matplotlib. In folder, what you'll have inside a folder, you'll have subfolders. Yes, we'll have subfolders inside matplotlib, obviously. This is matplotlib and this is inside of matplotlib. What I'm trying to do is, I'm not importing matplotlib completely. I'm just importing pyplot, one of these subfolder, only pyplot. Okay, so this dot is representing hierarchy. Import matplotlib dot pyplot as plt. So this plt is given as an alias name for matplotlib or pyplot, friends. Is it given plt is given as an alias name for matplotlib or pyplot? It is given as an alias name for pyplot. Why? I'm not importing matplotlib. I'm importing pyplot. No, 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 no. It is given as alias name for only pyplot. Don't get confused. See, that is the reason, why I'm explaining in this way. Assume matplotlib is a folder. How do you have folders in your system? Okay, in your PC, under folder you will have subfolders. So under matplotlib you will have subfolders. Okay, one of the subfolder is pyplot. Okay, why am I importing only pyplot? I'll tell you later, not now. I'll tell you what is the reason for importing only pyplot. Why not complete matplotlib? Okay, but the thing is, I'm giving an alias name called plt. Am I giving this plt alias name for matplotlib or pyplot? If you have the question, the answer is pyplot. It's not matplotlib. Okay, don't get confused. It is pyplot. Right. Now, and I'm importing cbon as SNS. So, if you observe here, we had two new packages into the picture. Matplotlib, cbon. Matplotlib and cbon are two packages which are used for data visualization. In order to visualize the data, we can use matplotlib or cbon. Then what is the difference between these two? Matplotlib is a basic visualization package, whereas cbon is an advanced visualization package. I hope it's clear. Now let me execute. So importing pyplot from matplotlib as plt, done. Then importing cbon as SNS. This is also done. Okay. Yes, for visualizing the data. Yes. Right. Now I am trying to read the data which is present in an offline CSV file. And where am I storing the data? I am storing the data in iris underscore data variable. What is the size of the data set, friends? What type of object it is? It is a data frame. What is a data frame? Data frame is a two-dimensional object, okay, which is similar to a table. Okay, and the size is 150 rows and 5 columns. Good. Okay, now let me get the info of the complete data frame. For that, I am using info function. Okay, what is a function? A function is nothing but a block of code or lines of code. So info function, I am going to work on iris underscore data frame, and this will result me the complete information regarding the data set. See, it gives me the information about number of columns, number of rows, and it talks about each column and the non-null count and the data type the same, and it is observed that there is no column with null values. All of the columns have non-null values only, right? And it is clearly telling that it is occupying 6 KB with respect to the memory, right? Now let us visualize the data, friends. For that, I have to do one thing. 1 minute, right? What is the first plot that we have discussed? What is the first plot that we have discussed? Is it bar plot? Yes. So in order to visualize the bar plot from PyPlot subpackage present in Matplotlib, we have bar function. Okay, all the plots that we have discussed, bar plot, histogram, box plot, okay, even the bivariate plots functions are also available in this PyPlot subpackage only. So that is the reason I have imported only a subpackage, not the complete package. Okay, so let us understand how are we going to create a bar plot. Plt dot bar has bar is the function used to create a bar plot, and this bar function comes from plt pyplot. Okay, like how read underscore csv is coming from pandas, in the same way bar function comes from plt pyplot. Okay, so under this bar function you are supposed to pass two arguments. One is height and the next one is x. Height is representing your data and x represents the values for the y values, nothing but height. Okay, to height, what am I passing? I am passing my data iris underscore data, which is nothing but the data frame dot sepal length, one of the column. So this column data from iris data frame, okay, from the iris data frame, this column will be taken and the values of sepal length will be assigned to height, nothing but the y-axis. What about x-axis? X-axis takes, sequential numbers. What will be the output for this, friends? Np dot a range of 0, 150. What will be the output? Output for the selected part. What will be the output? Np dot a range of 0, 150. Right. So this is nothing but it's part of. No. I'm just asking about this. See, I want you guys to answer me what will be the output for this selected part. Will it display? No, friends. That's what you guys are getting confused. Have are we not discussed about arrange function coming from numpy 0 to 149 numbers? Why are you struggling? It's not 0 to 150, it is 0 to 149. That's what I'm asking you to do hands-on from day one. Majority of you are skipping. Okay, so this will return me numbers from 0 to 149. So in total, how many from 0 to 149? It's nothing but 150 numbers. Am I right? Yes. In total, it is 150 numbers that we are getting assigned to x-axis. Why are we assigning 150 numbers to x-axis? Because for height also I'm passing 150 values. Because if you observe, how many values do we have under sepal length? 150. Okay, you are supposed to pass the similar value for x-axis also. So that is the reason I am passing 0, 150. Okay, so let me run this, and this will result me a bar plot for sepal length. See, do you understand anything by interpreting this bar plot? We should generally have bars, and the bars are just converting into small lines just for 150 records. What if I take 500 records? I can't even interpret anything. I can't even understand anything. So that is the disadvantage of visualizing bar plot. It's not an ideal plot for understanding data distribution for large data, so we generally ignore bar plot, but we should at least know how to visualize bar plot, and this is the process. Right? Now let me ask you a question. I'll remove this. Will it execute? NP dot a range of 150. How many values is it going to give me? Will it execute or not? Okay, my friend says yes. How many values it's going to give? Will it give only 149 or 150 values? It gives me 150 values. Don't get confused. Even though if I don't mention start value in arrange function, by default it takes 0. Python. Python basics are very important. Why? Because all of these things we are going to do with Python only. Okay, so even though if I don't give 0 in the same line, even though if I don't give 0, it still generates 150 values. Why? Because the start default value is 0. Either you mention or you don't mention. It starts with 0. Let me check. Will it give 150 or not? Yes, it's giving me the plot, the same plot. Okay, so this is also perfect. What if I do one thing? I'll do this now. Will it work? Will I get a bar plot now? NP dot a range of 151. Will I get a bar plot now? Okay, my friend says no. Why no? Why no? What might be the reason? Why can't we visualize a bar plot? Exactly. Good. The reason is, how many values are you passing for height? 150 actually. How many values are you passing for x? I am passing 151 values. How come? Because by default it starts with 0, right? So np dot a range of 151 will generate numbers from 0 till 150. So in total there are 151 numbers for x and 150 values only for height. So this should return as an error, and it should return as a blank, visualization. If you observe here, you'll see value error. Shape mismatch. Objects cannot be broadcast to a single shape. Mismatch is between argument 0 with shape 151 and argument 1 with shape 150. Clear? So it tells that we are passing 151 values for x and 150 values for height. Okay, now my friends understood. Now let me ask you, will it work? Will it generate a box plot now? Sorry, bar plot now? NP dot arrange of 1 comma 151. Will it generate a bar plot now? Yes. or no? Yes or no? Okay, my friend says no. What about others? Will it generate a bar plot now? Yes or no? Okay, some say yes, some say no. Some people say yes. Let me execute. Still, it is generating. Why? The reason is it's very simple, friends. The number of values that you are passing to height, the same number of values you have to pass for x. You keep any numbers in this, arrange function, but at the end of the day, the number of values that x take should be equal to number of values that height takes. But why did it generate? It generated because still it is generating only 150 values. And how can you say no? Okay, it generates. The reason is number of values that x is taking and height is taking, both are same. I hope it's making sense. Now it's clear. Okay, now let us proceed to the next column. Petal length. So again the same syntax, plt dot bar, which is function and which is coming from pyplot. So that is the reason I'm using plt, which is representing pyplot. I have given an alias name, right? So plt dot bar of height is one of the argument, and I'm passing the data petal length. Iris underscore data dot petal length, the next column in the data frame, and these values will be assigned to height. How many values? 150 values, right? And I have to generate 150 values for x as well. Okay, so how can we generate 150 values for x? You use range or arrange or whatever it might be. Okay, you are supposed to generate 150 values for x. Now tell me, will it execute? Will it give me a bar plot or not? Will it give me a bar plot? Yes or no? Yes, it will give me a bar plot. Let me execute. See, this is for petal length or petal width, petal length. Okay, so it will generate bar plot. Good question. Let me remove 0. Now, will it execute? Will it give us the visualization? Will it generate the visualization or not? Yes. Still it generates the visualization. The reason is, I'm passing 150 values for both x and y. So it generates a visualization, nothing but bar plot. Right. So it's very clear with respect to bar plot and the disadvantage of bar plot. So in order to understand the data distribution, okay, in order to tackle bar plot's drawback, we have histogram coming into the picture. So histogram, plt dot hist. What is plt? Plt is nothing but pie plot. Like how bar is available as a function to visualize bar plot, in the same way we have hist as one of the function under plt, pie plot. Okay, so hist is one of the function, and for hist you are supposed to pass only one argument. What is that argument? The argument that you find here is it's nothing but the data, the column. Since it is univariate plot, you are supposed to pass only one column at a time. So what is the column that I am passing? I am passing sepal length. Okay, let us visualize histogram. So this is the histogram for sepal length. Now tell me, is sepal length left skewed or right skewed? Because we understood skewness, right? Is it left skewed or right skewed? Comment. Use the chart and tell me the data that is present in sepal length, is it left skewed or right skewed? Right skewed. Good. How Akhil, what is the process that you are generally using to comment skewness? Simple. Connect it. Connect all these bins. When you try to connect all these bins, the top bins, you'll understand. Where do you find the long tail? Might be towards right side, but I don't see a long that much big tail. A small tail is what I observe. So might be, partially right skewed, not completely. So I can comment in this way as well. It is not that much right skewed, but partially a bit, right? Yes. Is it clear? Right. In the same way, let me also do it for petal length. Let me visualize a histogram for petal length. See, what is the difference between line number 20 and 21? Is there any difference with respect to the syntax? No. I'm just changing the column, that's it. I'm changing the feature and this will generate me, you know, the histogram for petal length. See, and if you see, it started with a peak, then there is a drop, then it started again, there is a peak, then there is a drop. What can you comment with respect to such kind of data? This is a histogram for petal length, and this is where my peak starts. It gradually came down, and again it started here, somewhere here, started, you know, started. Again, there is a peak coming down, 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 down. What can we comment? Can I comment in this way? I see two peaks, peak 1 and this is peak 2. But are these of both same size? No. There is no, both the size of these bins are not same. But in general, if you observe, it is actually making two separate peaks. So peaks generally represent, groups. Might be this data belongs to one group, and this data that we have in the second peak, under the second peak, can be part of the other group. So cluster 1, cluster 2. Okay, so this is the next topic that we are going to understand. So just focus. Right. I hope histogram is also clear, but understanding histogram and understanding bar plot is something very important, friends, because bar plot has a disadvantage. The disadvantage is it cannot be visualized for large data. So we are supposed to visualize histogram when it comes to data understanding. If you want to understand the data distribution, so you are supposed to visualize histogram. Right. Now comes, what are we trying to visualize again? I'm trying to visualize histogram again. Okay. I'm trying to visualize histogram again. But the thing is, I'm customizing my histogram. Okay. What is the requirement? Why are you customizing? If that is a question, let me execute line number 20 again. Can someone tell me how many bins do you find in this visualization? How many bins do you find in this visualization? My friend says 8. Do I have only 8 bins? Are you sure? Yes, 10. It's 10. How come 8? Hmm. Just calculate, friends. Bin. Bin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it is 10. Not 8 or some other number, it is 10. But the question is, why only 10? I hope you understood my question. Why 10? Why not 5? Why not 50? Why not 100? Okay, this is a general question that we have in the mind, right? See, you're generating histogram, that's fine. This is perfect. Why in blue color? I want it in red color. I want it in black color. So, in general, that these are nothing but your customizations. But who told the histogram to give the default one in blue color, or who told to give in 10 bins? Did I specify anywhere? Show me in the code. Did I specify anywhere? No. I just specified that this is the data that I have to use for the histogram. How come it is 10, friends? I did not specify anywhere in this line of code, but still it is giving me 10. If you want me to execute one more time, I do it again. Still it gives me same 10. 1 minute. Hold on. Changed. See. Still it is giving me, blue color with 10 bits. How come? If you have such kind of questions, the answer is very simple. What is the answer? Can someone tell me? What is the answer? PLT, or let me keep it as like this. Hist function in PLT. PLT is a standard, friends, which is given for pipe plot. So I'll show you why it is giving you in 10. Okay, so PLT documentation. Okay, so you have to go and visit the official documentation of matplotlib.pyplot.hist, because I'm using hist function, right? So this is old one. Let me show you the new one. This is still going. Yep, right. PLT dot, I mean matplotlib dot pyplot, right? So under this, I'm supposed to go and visit hist. Let me show you here. It is arranged in alphabetical order: G, H, P, matplotlib.pyplot.hist. See. So this is the official documentation of histogram. And let me show you the arguments that can be used inside histogram. How many arguments do I have inside histogram? There are n number of arguments. Out of these n number, how many arguments am I using? I'm just using only one. What is this one? It's nothing but x. What is x? X is nothing but it's representing the data input values. This takes either a single array or a sequence of arrays which are not required to be of same length. Okay, so you need not specify or give arrays of same length, right? So I'm just passing only one column of data frame to X. Now let me come down. Next to X there is bins. Yes, the next parameter that I have in the function is bins. Bins. Did I specify bins in this line? No. But if you see here, by default it is 10. Is it clear now? Why it is giving us 10 bins by default? So this is the actual reason. My friends, start reading documentations of these functions. Only if you understand the documentation of function, then you can play with the function. See, I'm playing here. How? I'll customize my histogram now. If you want me to do it, see, I'll do it. I'm executing all these lines of code at a time. I'll explain you, but let me execute and I'll make my histogram look pretty, beautiful. Okay, I'll make it very beautiful. I can customize it. So for that, I'm using some parameters. Right. So the first, let me talk about line number 24. In line number 24, we have figure function. PLT from pyplot. I'm using figure function. Okay. Under figure function, I'm actually fixing the size of the figure 8 by 5. When I execute only line number 24, it generates 8 by 5 a figure of 8 by 5. Okay, then in this figure I want a histogram. Okay, to this histogram it has to be plotted on sepal length column of iris underscore data, and the bins that I want is, I don't want by default 10 bins. I want only, the bins between this range 4 to 5, one bin, then 5 to 6, the other bin, 6 to 7, one bin, and 7 to 8, one bin. In total, you will have 4 bins. Values which lie from 4 to 5 of sepal length will be in first bin. Values of sepal length which lie between 5 to 6 will lie in second bin. Similar to 6 to 7 values lie between third bin, and 7 to 8 between values lie in fourth bin. And these bins I don't want it in blue color, I want it in red color. I'm changing the color of my histogram, and each and every bin should have an edge color that is black. For better understanding, let me make it into multiple lines, all these parameters into multiple lines. Yes, now it's clear. Then I also want to give an X label, a label for X axis, that is sepal length, and for Y axis I'm giving a label as frequency. Okay, X label and Y label are two functions from same pyplot, and to this entire histogram I want to give a title. It is histogram of sepal length with custom bins, and finally show function from pyplot which helps to display the figure. So this, all these lines you have to execute in one single go, then you will get the visualization. Is it clear now? Okay, I hope it's very clear. Previously by default it gave us 10 bins, but is it giving us same 10 bins now? No, I am making it customized. I want it only in 4 bins. 4 to 5, 1, 5 to 6, 1, 6 to 7, 1, 7 to 8, 1. And this the total histogram should be in red color, and each bin should have an edge color black. So in this way I am playing with the parameters of histogram function. Where are they actually available? In the documentation. See, bins. I don't want to go with an integer. See, for bins, you can directly pass an integer or a sequence or a string. What did I pass? I passed the sequence. Then next to bins, we have color. By default, it takes none. I'm giving it as, red. Right? So all these are the parameters that are available inside histogram. Right? Histogram is clear. In that way, you can do it on multiple columns. Okay, try it on multiple columns, customize them, play with the parameters. But before you go and visualize histogram or bar plot, any visualization, try reading the documentation, because if you read the documentation, it will be very clear and you'll rock. Right. Now let me go and plot box plot. Let me visualize box plot. Okay. So box plot is the only visualization which is used to check, which is used to confirm outliers, and this box plot is available as a function in pyplot. So plt dot box plot, the function, and it is also expecting only one parameter. It is nothing but the data. So I'm passing sepal with column. Let me execute. Oh, so in sepal with column, there are outliers, but that box plot that you see is in vertical direction, right? It's not horizontally aligned, it is vertically aligned. So you just tilt it 90 degrees, you tilt it towards your right side. So this will be your upper limit, this will be lower limit. Let me mention them. Upper limit, lower limit, Q1, Q2, Q3. So towards upper limit, how many outliers you found? How many outliers are there with respect to upper limit? And how many outliers do you have with respect to lower limit? Come on friends, comment. How many outliers do you find towards upper limit and lower limit? Okay, don't just count these circles and tell I found 3 outliers towards upper limit and 1 outlier towards lower limit. No, it's a blunder mistake. The reason is box plot, it talks about the presence of outliers. Yes, I can comment whether I have outliers or not. Yes, but is it also talking about number of outliers? Will it talk about number of outliers present in the data? No. Okay, this is not actually the part of box plot. You cannot also comment in this way because I'm just working on 150 records, a small data set. What if I work on 1,50,000 records? Are we going to sit and count on all these, circles? No. The reason is sometimes the outliers might lay on the same circle multiple times, but we assume it as only one. What if there are 4 values of same? If there are 4 same values, and it will actually show it as only one, but it is actually 4 outliers. I hope you understood my point. So this is not actually part of box plot. We are supposed to do it using a logic that that we'll discuss in the coming classes. But box plot, it is actually displaying the outliers, presence of outliers or not, right? So this is with respect to box plot coming from matplotlib package. Let us also visualize box plot from C1 package. Let us see. SNS is representing C1, right? So let us see. Oh, so what is the difference, Akhil? I see the same box plot in the previous, visualization as well. The difference is, my friend, if you observe properly, in the previous case, is the box shaded with any color? No. Right? Whereas in this case, you'll observe the box that you see is shaded in blue color, and moreover, the box that you observe is bulged out. So this is actually the difference between Boxplot function from Seaborn and Matplotlib. A basic package and an advanced package. What is the difference? There are some differences with respect to the visualizations. But ultimately, the aim is same. It is also displaying that there are outliers in the column. Nothing but sepal width. Petal width, let us check. So there is no outlier. But is the data normally distributed? Can you comment on normal distribution with respect to this box plot? Is it normally distributed? No, the answer is no. Because if it is normally distributed, you should observe that both the boxes should be identical. Are these both boxes identical? No. Even the whiskers are also not identical. So data is not normally distributed. So that we can interpret from this box plot. But when it comes to outliers, there are no outliers in this column. Okay, what is the column that we are working on? Petal width. In petal width column, there is no outlier, but data is not normally distributed. Okay, so I request everyone to do hands-on with respect to data visualization. Under data visualization also, we have completed only univariate plots. We'll be discussing bivariate plots in the coming session. But for the time being, you take any data set and try to visualize the plot. Okay, when you visualize the plot, only then you will get the hands-on done properly. Right, let me take your technical questions. Is there any way to check how many outliers are? Yeah, that we'll discuss, my friend. In the coming sessions, we are going to discuss how many outliers are present in the data. Yep, we'll discuss, but not using Boxplot. There is a different technique we'll discuss. When I'm running the code, the plot window is not getting opened. What I have to do? Okay, my friend, I have changed the settings in the spider, but you'll not get the visualization in a separate window. What you'll do is in the spider itself, go to. Okay, let me share my screen once again. You will get 1 minute. 1 minute. That's what I understood. See, what you'll do is in the plot section itself, here itself you'll get the plots. I have changed the settings, so I'm getting as a separate window. But under plots pane, you'll get the plots. Right. It's just for visualization. Yes. Even yeah. So I request everyone to do the same. Go and check under plots section. Under plots pane, you'll find that plots when you run the code. Right. So the feedback form has been provided. I request everyone to give you a valuable feedback before you leave. And in the same way, I request you to also share these videos, these sessions to your friends, your community, various across various multiple channels. And before you leave, just hit on the like button. And if you have any kind of technical questions, use comment section. We'll reply with a proper answer. Right. So thank you so much, friends. We are done for the day. We'll connect tomorrow, probably on the next day, and we'll continue with our other topics. Thank you so much for joining. Have a great day. Sign off.